Science in pajamas. Boop, boop. Alright, guys, welcome back. Today we're going to talk about how to resolve a vector into its x and y components, as well as how to find the resultant. We're actually going to start by just looking at how to find the resultant. So let's go ahead and get started. Here's our first problem. This one's just kind of a review problem. So a truck drives 15 kilometers east and then turns and travels for 6 kilometers west, then turns again and drives 22 kilometers east. What is the distance and the displacement? Now, something that's good to do is to diagram what's going on in the problem. So we have our truck driver, and he is going 15 kilometers east. Then he turns around and heads 6 kilometers west. Then he turns around again and heads 22 kilometers east. So what's the distance and what's the displacement? Now remember, distance is a scalar quantity. It is simply an amount. So what is the full path that is traveled by this truck? Well, to do that, we simply add it up. We have 15 plus 6 plus 22 would give us 43 kilometers. So the distance equals 43 kilometers. But displacement is looking at the change in position from where the truck started to where it ended. So what is that value? Now remember, this is where direction comes in, because displacement is a vector quantity. It needs direction. And what's one way we said we can take care of direction? Is by using positive and negative signs. So we had previously said up and right are positives, down and left are negatives. So we're going to do 15 to the right plus negative 6, because that's heading in the opposite direction, plus 22 to the right. So 15 plus negative 6 plus 22 would give us 31 kilometers. And in which direction did they end up? East. The displacement equals 31 kilometers east. So the truck ended up, even though the truck drove for 43 kilometers, it ended up 31 kilometers east of its starting position. All right. Now, how about we get this and make it a little bit more challenging? Shall we? Let's talk about some two-dimensional motion. I have a doggy. The doggy is going to chase the squirrel for 10 meters north and then turns, and the dog runs 5.2 meters east. What is the dog's displacement? So if we were to look at this, and it's oftentimes good to kind of diagram it. The dog runs 10 meters north and then turns and runs 5.2 meters east. So we want to find the displacement. Now, a nice thing about it being north and then east, we know that's a 90-degree angle. So what we can do now, if we know the two sides of the right triangle, we can figure out the hypotenuse using Pythagorean theorem. So the resultant equals square root of x squared plus y squared, which is just a rewriting of the Pythagorean theorem. Remember, Pythagorean theorem is a squared plus b squared equals c squared. We just simply replace that as x squared plus y squared equals r, the resultant squared. So go through, I can plug this in. R equals square root, actually no, is right here. So square root of, let's see, we have x is 5.2 meters squared, meters, and we're going to take 5.2 squared plus 10 meters, and we square that, and we end up with, let's see, 11.3 meters. Now don't forget, this is displacement. What does displacement require? It requires a direction. Now knowing how squares and rectangles work, we can also understand that 5.2 meters, those two should be the same, and those should be the same. So what we're going to do is we're going to find theta. And we do that using our inverse tangent. So theta equals inverse tangent y over x. Opposite over adjacent. If we're looking at this theta here, opposite is the y over the x. So theta equals inverse tangent of 10 over 5.2 equals, and what do we get? We get 62.5 degrees, and we have to give a reference for it so we know, where it's located. And we can say north of east. So that tells me that if this line here is straight east, then if I go north or above that for 62.5 degrees, that should tell me where I'm going to end up. All right, so far so sorry about that. So far so good. Let's try another one. I have some cereal caught in my throat. Alrighty. So now we have a pirate. The pirate walks 43 meters north and then walks 11.2 meters east. What is the displacement? Well, we're going to do just like we did before. I'm going to find this value, which is r. So, yay for the good old Pythagorean theorem. So r equals square root of x squared plus y squared equals square root of 11.2 squared plus 43 squared, and we end up with 44.4 meters. So that's the displacement. Again, displacement is a vector, it needs a direction. So that means we've got to find the theta. So theta equals inverse tangent of the opposite over adjacent. So the opposite would be the y. over the adjacent, which would be the x. And we get, for our angle, it would be 75.4 degrees. And we can say, since it's right there, and we know this line is heading east, it is 75.4 north of east. .4 degrees north of east. This is a complete answer. It tells me my displacement and the direction of the displacement, because displacement is a vector. It needs that direction. All right. Change it up just a little bit. Yeah. Can't read that for a minute. Yeah. All right. What if we know the angle and we know the resultant, but we want to find the x and y components? How do we do that? We'll show you how. So a truck is moving for 27.3 kilometers on a hill at an angle of 19 degrees above the horizontal. So it's heading up the hill, 27.3 kilometers, and the hill is at an angle of, okay, I need to put that because I know what it is, 19 degrees. We have to find the x and y values. So the x component and the y component. Well, since we have our hypotenuse, our resultant, and we know the angle theta, we can actually go through and solve this using some of those trigonometry functions that we mentioned before, sine and cosine. So for the y component, we use the hypotenuse times sine of the angle theta. So that equals 27.3 times sine of 19 degrees. And we get 8.9 kilometers. 8.9 kilometers. And to find x, it is the hypotenuse cosine of our angle theta. So x equals 27.3 kilometers times cosine 19. And for that one, we get 25.8 kilometers. And guess what? That one's done. We're all done with that problem. See, that wasn't so bad, right? These ones are actually pretty easy. Let's do one more like that. Come here, board. Yeah. Haha. All right. So now we have a plane flies for 572 kilometers at an angle of 68 degrees north of east. What are the x and y components? So we have 572 kilometers. I'll find the x and the y. The angle is 68 degrees north of east. All right. So again, we know our hypotenuse, it's 572, and we know our angle, which is 68. Find the y component, we have to take the hypotenuse, multiply it by sine of 68. And for that, we get 530.3. kilometers. For the x component, we know our hypotenuse, 572. We know the angle, so cosine of 68 degrees. And we go through, we plug that in, we get 214.3 kilometers. 214.3 kilometers. See? Not horrible, I hope. Alright, well, I hope this kind of helped you guys out a little bit. If you have additional questions, definitely let me know. But yeah, I mean, that's how you find resultant quantities, as well as finding the x and y, so resolving the vector into its x and y components. Hope it helps, and take care, everyone. All right, bye-bye.